Good morning, eCognition oil palm application users, or good afternoon, wherever you may be in the world. This is Keith Peterson. I am the product manager for our Trimble eCognition software products. And today we are going to talk about what is new in eCognition Oil Palm application 1.3. This product just released yesterday, so any of you that currently are under maintenance should have received the information that the product is available for download, and you can start using this. But if you want to learn what's new in the product, then this is the perfect opportunity to get a jump on things and an early start on how to use the new features that are available. So this is what we will go through in the next slides, and we will also look at a live demonstration of how this product has changed. Just an overview. We will do an introduction to the eCognition Oil Palm application itself in case there are any new users or people that are interested in this product and have not used it before. Then we will look at what's new in version 1.3, like I said, just released yesterday. And then we'll actually look at working with the Oil Palm application in a live demonstration. Before we get too far into the webinar, I just want to mention this webinar is being recorded. So if you have to jump out at some point or you miss something that we discussed, it is going to be available through the Trimble Geospatial Webinar website. You can then access the archive anytime you like and replay it. That being said, if you have a question that comes up during the webinar, please feel free to use that question dialog field to ask your question, and one of our participants here in the office will answer that, and we will also take breaks to answer your questions throughout the webinar. So that's the overview of what we will be doing today. And like I said, if you have questions, please chat with us via the question dialog at any time. So an introduction to the Trimble Oil Palm application. First of all, this is an out-of-the-box solution specifically for the identification and analysis of oil palm trees. It is utilizing our very strong and powerful eCognition technology, but we've put a easy-to-use graphical user interface around it and created a guided and automated workflow for the users to easily step through this analysis. This means that there's a low ramp-up time, and it requires very little pre-knowledge of eCognition, of remote sensing, or even of GIS. It's really aimed toward a broad range of users in the oil palm industry, whether it's going to be an operator or a manager of a plantation, or maybe those GIS specialists that are providing services to such plantations. We address all audiences here. Okay, this is a standalone product. It means it will work without any of the other eCognition products, such as eCognition Server or eCognition, any parts of the eCognition Suite or Essentials. So, but of course, it can be integrated into our other Trimble platforms. The real benefits of the eCognition Oil Palm application are that its users get precise and accurate information of their plantation, an overview of the current state of growth within the plantation. Also, it allows its users to create what we call actionable data out of these UAS data sets for the plantation. That means they can walk away. They have, for example, the number of palms and various statistics on those palms that they can take and make crucial decisions right there. Also, it just makes for faster and better decision making, even on the per tree basis, and this will increase production yields and drive what we hope sustainable plantation operations going into the future. What type of outputs are available from the eCognition Oil Palm application? Well, of course, we do the tree counting, so we find tree positions. This is then, for example, available as a point shape file that contains the tree center points and then all the various attributes that are associated with that tree based on the input data that the user has plugged in. In addition, the user can export tree crowns. This is then a polygon, and it's a representative polygon, so small, medium, large. And this will then also be associated with any of the attributes available for that the center, the point file. Just another option in terms of exporting a product out of the Oil Palm application. New in eCognition 1.3, and we'll get into the details a little later, is gaps. So these are, as we can see in the screenshot in the lower right-hand corner of the slide here, it's a polygon, and it will represent unplanted areas within the plantation. And with this, we of course export attributes such as area, so that an operator knows how much land within their plantation is available for planting or may not be utilized to its fullest extent. Also, the blocks themselves, so these blocks, this is how the plantations are split up into different groups. These are available as a polygon shapefile for export, and they will contain, say, an overview of the different statistics of the attributes that were evaluated above. So we will, of course, have a readout on the number of trees per block, the number of large trees, small trees, trees that are maybe stressed within each block. So it will give you a summary of the different pieces here. The eCognition Oil Palm solution, it bundles the Oil Palm application with other Trimble platforms, like I mentioned earlier. And we combine with complementary Trimble technology to provide a geospatial ecosystem that can be created to support an informative and repeatable workflow. And this solution is made up of a close consultation with plantation managers and growers. So we approached them to see what they needed to really push sustainability and look at the financial planning aspects of these plantations. So it goes through the collection, the processing, the modeling, and of course then the analysis of the whole plantation. Within the collection, of course, Trimble offers a range of hardware products that are obviously benefit any plantation operators, giving them more accuracy in the data that they are actually acquiring. This could range from a Trimble R9S or even in the past the Trimble UAVs that were available. Could go through to a Geo 7X and a Catalyst system for collecting various data within the field. And of course, going through this whole system, we can guarantee that high level of accuracy and the highest possible product quality that there is. Within what we call the data processing, there are several options, either going through, say, the TBC base module. So that would be processing that UAV data that you collect, whether it's going to be through a Trimble solution or a third-party solution, or, for example, the UAS master product, which is also available within as a TBC module itself to create those ortho-rectified images, and of course elevation products that are an advantage when doing the analysis. From here, we take those products out of Trimble Business Center or UAS Master, and we bring them into this final piece here. This is what we call the analysis phase, and this is where the eCognition Oil Palm application is then utilized, and then we can, of course, take our exports from this. So this is just an example of what we call this complete Trimble-based solution. It is available and will, of course, have its benefits for our users. So in the end, when we use this solution, it's all about creating this actionable spatial data, and this comes out of then the eCognition Oil Palm application. It flows back to plantation managers or the people in that chain of command to make their decisions. For example, check a certain palm within a certain block because it has been flagged as an anomaly or as a stressed tree, whether that tree is too short or not getting enough fertilizer or maybe getting too much water. These are things that then the managers can check in the field in a more efficient way, not having to go out and just look at every single tree. We can provide them with the location-based data to really focus their efforts in certain parts of the plantation that need to be addressed. So, what is new in Oil Palm version 1.3? We've been working over the last year here to make improvements to this product, and what we've really focused on is extending our analysis capabilities. So, providing more tools within Oil Palm, the Oil Palm application, but trying also to keep these tools in an easy-to-use format. So what we've done is we've added this gap detection support. Like I mentioned earlier, this allows users to look for areas of the plantation that are not being utilized to their fullest, so looking for areas that are available for additional planting. And we will see the intricacies of this tool in the demonstration in a few moments. We've also improved the deliverable packages in part to reflect the new information that we're creating through the gap detection, but also providing better screenshots and more understandable statistics within the PDF report, which is also an option for exporting beyond the shape files. So you have improved visuals within the reporting packages. And finally, just increasing workflow performance, making improvements to the manual editing tools and report generation, as well as making certain bug fixes that came up during, of course, during the phase of the Oil Palm application 1.2. These have been fixed and implemented within the version 1.3. So these were the three areas that we really were tackling with version 1.3. That being said, before we move on, are there any questions that have popped up while I've presented so far?
Hi, Keith. At the moment, everything's pretty quiet here. No questions from the audience, so I think you can go ahead and present.
All right, Matthias, thank you. Like I said, again, to anybody who may have just be joining the webinar, it is being recorded, and you can use the questions dialog to ask questions at any time, and we will either give you a written answer, or we will discuss this in the course of the webinar. So let's get back into our presentation. It's time to dive into the live demonstration of the eCognition Oil Palm application 1.3. So if this is the moment you've been waiting for, we will unveil the new software that is available for download as of yesterday. This is what it looks like. The look and feel has been pretty much maintained. Any users that are familiar with the package will see a new action group here, the detect gaps. This is the new functionality that has been added, and we will get to this as the time comes. So for those of you that have used the eCognition Oil Palm application, please bear with us, but you may learn a few little tips and tricks from our side. For those of you that are completely new, this is what the eCognition Oil Palm application looks like. It is a out-of-the-box application, so that means it comes with a set of actions, a set of rules that are to be applied via a graphical user interface. So if there are any developer users out there, don't be scared. You don't see a rule set. That's because this has been turned into this graphical user interface to allow a simple and a straightforward use of the product. The first step, of course, is getting our data products into the eCognition Oil Palm application. So you've done your flight acquisition with a UAV. You've processed that data in a package like a UAS master or info or those modules within TBC. You've created your ortho mosaics, you've created, say, an elevation product, and now you're ready to bring this data into the eCognition Oil Palm application. So what we do is we simply click on an action. It is highlighted here. Each action has a set of parameters that then become available in the lower portion of this window. So if I click on import data, I see that I have the options to add layer, I can close a project. So the first thing we need to do is actually add our image layer to the eCognition Oil Palm application. That being said, the Oil Palm application supports image layers, so raster formats. If you have a point cloud, sorry, that is not required for this application. You can certainly bring in elevation data, but it has to be in a rasterized format. So let's click this add layer. I'm going to navigate to my data sets here. I've actually have some here on my desktop. Here's my demonstration folder. I'm going to select my my orthophoto RGB. So here I've got a ortho image. It's a mosaic, and it's in RGB, red, green, blue. So we will click this and open this. Depending on the size of your image, it may take a few moments to load into the viewer. Here it is. And the next step is to then tell the Oil Palm application what bands, so this image is of course red, green, and blue, but which of these bands corresponds to the actual red, green, and blue bands. This will depend on the sensor that you are using. And since we opened up the eCognition Oil Palm application to third-party UAV sensors, we need to account for some of the variability in how they actually deliver this data. So this is where the users can then come down into these fields and determine this. So I know from my provider that my red is going to be band 1, my green is going to be band 2, and my blue is then the band 3. Those are the defaults here. Of course, if you have a fourth band, say that near infrared, also very good to have in eCognition, you can leave that as unassigned. We will still read it. Don't worry, you don't have to define that band here, but we can still utilize that information at a later point within the analysis, which I'll point out when we get there. From there, we also have the option of going into these general settings. So here I can select what area unit do I want for my reporting, and we can select square meters, square kilometers, acres, and hectares, hectares being the default. So I'll leave that default value of hectares, but just know as a user you can change those units that will eventually be used in some of the outputs. Finally, when you have these settings complete, we just click on confirm, and once I do this, I will notice that I have a check mark within this action. That check mark means that I have fulfilled the minimum requirements for this particular action, and I can continue on to the next action item in the Oil Palm application workflow. So before we do this, have any questions popped up on project creation, data input, or any of these subjects?
Not yet, Keith. I think everything is pretty clear, at least for the audience. So I think you can continue with the presentation of the software.
Okay, we will move on. So the next step here is called LowDefined Blocks. Now this comes from our close work with Oil Palm consultants, that these plantations are organized into what are called blocks, and the user has the option of, if they have their blocks established, they can load these, or they can use a manual creation. So there are tools to draw the blocks in manually if they would like. You can import this from a shape file. So that would mean you'll have to have that in a GIS shape file format. Alternatively, you can also just simply use the entire scene if you would like to. So I have in this demonstration data set of my blocks saved as a shape file. So I'm going to click this option. Once I do this, the tools change slightly to allow me to select and browse to this shapefile. So I'm going to browse to the location. I see here this is my block.shp. I can simply select this and click open. Once I do this, I automatically start seeing the extents of my blocks here within the viewer. If you have numerous attribute columns within your shapefile that would define a block name, for example, you can select those. You could also edit certain block naming. So we have an ID field here that contains the name of our block. And now I'm going to click Save to lock these parameters in to the solution. You will notice once the save is complete, again, I have my check mark here indicating that I can move on to the next step. So the next step is the utilization of elevation data. And here again, the user is presented with several options to address as much flexibility that is possible. So by default, we will allow the analysis to continue without any elevation data, so without a digital surface model or a digital terrain model. Alternatively, we can reference any existing DSM or DTM that we may have created through such a product as a TBC or UAS master. Or the third option being, if I've only created my my DSM in outside of the oil palm application, I can actually estimate my digital terrain model based on this existing DSM. So in my data set, I have an existing DSM, so I'm going to select this and we can estimate the DTM from this. So if I select that, again, the options change here. I need to select the file that represents my DSM. I haven't loaded this yet. So remember, this is also a raster file. So I'm going to import from a new file here. And I can see here, elevation DSM is the name of the file that I'm going to use. Click OK. And this will be loaded into the project. I also then have options, and this impacts the digital terrain model estimation on whether I'm working in flat terrain or rough terrain, and the degree of roughness can be set here. So I know from the outset that this plantation is in a flat working environment, so I'm going to use this option of flat, and then I will click the Create DTM button. So this is now, we're estimating that DTM generation based on our DSM input. And again, based on the size of your mosaic, the size of your working area, this could take a longer time to run. So while this churns away, Matthias, are there any more questions on the line here?
Yes, we actually have one question. And that would be if the application is only for UAV data or if you also could use satellite data.
Excellent question. In the outset of the presentation, we looked at, we said this is for UAS data. So the oil palm application is only going to be effective if you have UAV data. Remember, we have to be able to see our palms within the data set, and the satellite data, although you can get some very high resolution satellite data, at the moment it is not supported in the eCognition oil palm application 1.3. So in the meantime, my DTM has finished processing here. I will click OK. I've been given the notification that it is complete. Once we create the DTM, and we also have the DSM, we then do some band math behind the scenes, and we create an NDSM. So this is a normalized digital surface model. And what this means is we're calculating the height above ground for any object that's elevated. So we're essentially setting ground to 0 or just about, and then we can actually have values in and of objects above ground, so that I would know then the height of a tree once I find it. You also have some options to do some editing here. You can manually edit the ground if certain things didn't work out right. In our case, everything looks very nice. I can see here the These are some much higher trees, probably older trees that are higher than here. We also have some of these smaller trees that have been already planted in between the rows here. So I'm going to save my results. I need to do this in order to advance. Again, I see my check mark. This means I can move to the next piece here, and this is the detect and analyze palms action. So here we have a number of tools or parameters available to this. First of all, when we do the palm detection, we utilize primarily the green band. So we have to define which of our bands corresponds to green. We did this in the first step, but if you want to base this on another band, you could do so. Our recommendation, the way we've created this product, is to get the best results based on green. You then have a sensitivity parameter here, so we can use this slider and increase or decrease sensitivity. Obviously, the higher I set this, the more sensitive the template is to finding a palm tree in the background. Just to let you know, this default value of 0.7 was what we found to be an optimal value based on the input of a Trimble UX5 at the time, which was used to develop this software initially. So if you're using another type of UAV, you may need to decrease or increase this value as you see fit. Feel free to experiment with this value and play with these sliders when you're doing the analysis. You really can't break anything within the oil palm application. We also have another option here just below, which is detect based on elevation. This is optional, so if you don't have elevation data available to you, obviously you can skip this piece. If you do have the elevation data available, so if I come up to my toolbar here, right now I'm simply looking at showing the ortho photo. If I come to the end, I can look at this NDSM, and I can see that some of these small palms are really best visible in my elevation product. This is an indication to me that elevation might be a good setting to use here, in addition to the sensitivity value, which is based on the optical data. So again, if you're working in an environment where you have some very small palms like we have down in this field here, feel free to increase the sensitivity of this elevation field here. I don't know, I'll try something like 0.45. Again, you can experiment and you can write over your results. If you're not happy, you can go back and make adjustments here to find the parameters that best fit your input data. We then move down here. We have the breakdown into now determining palm, the crown size. So we have small, medium, large, and we can adjust these settings to say, well, small palm is what I consider 2 meters in diameter, or 3. Again, the user can adjust these settings. These are the defaults, and I'm going to leave them as such. The bottom part here is for looking at anomalies or stressed trees. So for example, these lighter trees here are all indicating a stress. This is ideally done based on certain NDVIs, or Normalized Differential Vegetation Index thresholds. That requires the near infrared layer. I do not have this in my particular project. So I am going to then use, excuse me, the call came in on my computer in the meantime. I am going to just set these as not assigned. I'm not going to calculate whether a tree is has an anomaly or not in this case. So the last step is then to execute this action based on the parameters that I have defined here. So I'm going to now launch this and detect palms. And again, depending on the size of your image, this could take less or more time to run. If you're working in a huge mosaic, one of my recommendations to decrease some of the processing time is maybe just break that down into more manageable tiles for your particular computer. The eCognition Oil Palm app does not have any size restrictions to it. We can handle as large an image as you want to put into it. The restrictions really come on the individual hardware that you are using, and of course we have no influence over what computer you're going to be running this on. So if you find yourself with a computer that is running slow, maybe you want to break this into tiles and process one tile at a time when doing your analysis. So here it's already run through, and I see I have my tree crown polygons. I have different sizes available. I also have the point file, which is in this. If I zoom in, I can see that crosshair dropped nicely right on the center or near center of my palm. If I'm not happy with these results, so I can see I didn't get all the small palms in this field, I can go back and change some of my input parameters. So I can hit this revert, this essentially an undo button, go back now and adjust. Maybe I have to increase my threshold a little on this option for using the elevation, and again, run the detection of the palms. And we'll let this just run through again. I just really want to stress, please use the options here, these sensitivity thresholds, as they are required for your data sets. And you have these tools and you can adjust them. You're not going to break anything. So you don't have to just simply accept our default settings. You can use this in the way that best fits your input data. So as this runs, have any other?
Yes, Keith, there's one more question, and that would be if the parameters can be set per block. So in case they have several blocks with a different age of planting.
No, at the moment, the parameters cannot be set per block. But one recommendation is to, if you really want to set individual block parameters, you could use your blocks. You could split your blocks up into individual shapefiles, and you could run this individually on your image. So load in a block A, which would be palms, young palms, and old palms. The settings are not individual per block, but as you can see, if I have a block here that has young palms and blocks here that have sort of, let's say, a medium age palm in this particular scenario, and we have blocks here, if you looked at that elevation data, I'll switch this on again, we see that these blocks contain some of the oldest palms here just based on simply on tree height. But even if we use the overall parameters, we're still getting a very good detection of these palms here, as well as these younger palms planted in between. Where it becomes a little more tricky is some of the extremely young palms, because as you see here, if I zoom in, even in the elevation view, we're not picking up a huge difference in elevation, and that's one of the criteria for finding these very, very small palms at the moment. But again, you have the options to increase this sensitivity threshold, so you can use this and then go beyond just the parameters for individual blocks. So at the moment, I'm now happy with these results. I'm going to save. Now, I also saw in here that there are a few errors, probably caused by increasing that sensitivity threshold and elevation. We also pick up some other objects that could be elevated, but this is where we have tools to do editing, and we can come in and make some manual corrections to the results. Very simple. We can add, remove palms. We can edit the size. We can edit the anomaly. So here, for example, something triggered a palm in that roadway. Here also there might be some brush in this particular field. Here we can come in and quickly go through and edit some of these palms. So we also have a few missing here, obviously, but this is actually good. It will give us a chance to demonstrate the gaps. We can just make believe that some of these palms are actually not there. But to show you here, I can add a palm, and we can then come in, edit that size parameter simply by clicking on it and get it back to the very small size. So here too, maybe that should be really a small palm, and you can see that the user can very quickly come through and make adjustments to the results here. So again, something maybe we don't want there, and over here this looks very good at the moment, but here, for example, one was missed here as well. And maybe this is also a matter of just playing around with my individual sensitivity parameters here. But we'll make these edits. If you get to the point where you are happy, we can then save these results. That's critical, is to make sure you save your editing results, or you won't be able to advance because you don't get the check mark here. Even if you don't do any editing, you'll just have to save by default, and that locks in the overall results and allows you to move to the next action. So this is where we get into the new feature that's available in Oil Palm version 1.3. This is the detect gaps action. And again, we give the user options. Maybe you're not interested in finding any gap areas in your plantation, so you can just continue without doing this particular calculation. Alternatively, we can, of course, calculate the gaps. And here we have certain parameters that we need to fill out as a user. And these can be, first of all, the planting distance. I can use this slider to change my planting distance and to whatever is maybe established within this plantation. So I'm going to use this value of 9. I can also use a set of parameters, minimum gap area. I may not be interested in the very small gaps, for example. So I can set this to a certain level. It's, again, in hectares. So if I set my gap to the minimum gap area of, say, 2.5 hectares, I'm not going to include any gaps smaller than 2.5 hectares in this output. We can then execute this, and as it runs, we will also see here I found some gaps. Like I said, in reality there are some small palms planted here, but for the sake of the demonstration, we'll pretend that this land is available. So obviously if palms have been detected here, we wouldn't have calculated this gap area, and we can come in and find this. I can also visualize this based on a density map. So this may also be an interesting setting to use. So if this density layer in the background, obviously the redder this is, the higher the density is of trees in this area. So I can see that this corresponds well with some of the results in that density map, areas that do not contain any palms. This particular area up here is blue because it was not included in the analysis at all, as it was not in a block. So we can toggle that view on and off here. You also have tools for editing these blocks. So make sure it also gives me a good opportunity to point out this description field. If I'm hovering over a particular tool, I'm not sure what this tool does, you can read in the description field of how this tool works, or of course you can go into the user guide to get an explanation, a more detailed explanation. So if I want to edit blocks, you can do this. What it means, if I click this, I'm now entering editing mode, so I can see that this polygon is shifted. I see the outline as well as its nodes, and I can come in and right-click on a node. I can say delete node here, or I can come in and move these around if I need to, and I might need to come in and adjust this to account for this water area that is maybe simply just unplantable, and I can come in and make the adjustments as I need to. But it is possible to adjust these polygons here. If you do any adjustments, of course, make sure you click save. So if we then save our results, these will be locked in. I should mention when we do the gap area calculation, we are simply looking at a tree density and where there are no trees. We are not considering whether this is any type of land cover here. So if say a road is going through, or if there is a waterway here. So example here, it looks like we have some type of a canal or river system running through the plantation. This is currently not included as an area to exclude from the gap analysis, as are areas of a certain slope. This is something we will continue to look at for the next generation of gap detection tool in future versions of eCognition Oil Palm. But what we do provide is a useful indication of where there is available land for planting within the plantation to give those managers that information of where they can better utilize space within their blocks. So once I save those results, I get that check mark, and I can come to the final part of the workflow, and that is now the export piece. So we of course want to get this great information out of the eCognition Oil Palm app, and we can export various products. So we could export the tree centers, we could export tree crowns or the blocks. You don't always have to have them all. You can select whatever files you'd like. These get exported as shape files. And remember, if we have shape files, of course, we can look at attributes for those shape files. So we can open up to see what attributes are there. We can use the ShowHide Attribute table. And you see, for example, if I'm looking at the trees layer here, that I have a large number of attributes available. And this ranges from just a certain block number. So all these trees that are available here are in the block ID 100 that we took from our input shapefile. It's asked, we indicate whether that tree is an anomaly or is it in a stress condition. Remember, I didn't choose to run this analysis because I don't have that near infrared. So in this case, they're all going to be set to no. And then we also get an indication of its crown size. So whether it's small, medium, or large. And we also look at the density and then the actual physical position of this tree, those XY coordinates. In addition, you have an elevation value, so that's just the strict elevation of this location. And if you used any elevation data within your analysis, we can also calculate the height of that tree. So we calculate that NDSM layer. From that, we can derive the height of an individual tree. And finally, at the end of this dialog, there is this comment field, and this is indicating the method that was used to detect a certain tree. So you notice too, when I click on a tree, the viewer will jump to that tree within the center of the viewer. And you'll see here this is approach. Let's see if we can increase our size here. That the approach is I can tell you this has been used with template matching. Those smaller trees will probably be used an approach called a height difference. And if a tree was added manually, there will be that indication within the comment field that this tree was a manual correction. So you can quickly determine, say, the overall accuracy of this tool. And these statistics, by the way, they of course are exported with that shapefile. They are also summarized within the report. So I can pull up my block statistics. I can see then just the pure number of palms per block. I can get the number of palms per hectare. I also have then a breakdown by by the crown size per block, and whether it's anomaly or not. Remember, we didn't run this. And then you also have the amount of gap area, that being a new feature per block. So that we only had a gap in this one particular block, and that gap is approximately 0.28 hectares in size. So this is the information that would be then exported with that shapefile. Alternatively, you have the option of exporting a report. This report will be in PDF format, so you could also select this, and this report will provide a summary of the different statistics on block levels and total levels, and provide valuable visual aids on where certain aspects of the plantation were found. So you will get an overview visualization of each block, as well as then the breakdown of trees and et cetera found in each block. And then all you have to do is then click the export button. This will be put out, and you can then open these shapefiles in the GIS. You can open the PDF in whatever reader you have. And most importantly, with those shapefiles, and we get an indication that this was created. And with the shapefiles, you also have that DBF file, which stores those attributes. If you want to open that up in the Microsoft Excel, you can certainly do that, and then you can start to do a lot of analysis of those individual statistics within Excel and get the breakdown of each tree within your plantation. You can start to organize and do whatever you want in these types of statistical analysis software packages. So you have a lot of options on how you work with the information coming out of the oil palm application. So that is bringing us close to the end of the webinar. I'd like to now open it up to any questions that have come in during this presentation. So Matthias.
Yes, Keith. So we have one more question. I'm not 100% sure if I get it, but the question is, can we manually remove the water or road area from the detect gap process? Meaning the gap blocks could be split into few blocks per detection.
So if you want to remove, like I said, the current gap detection does not automatically filter out whether the surface is a road or water. You can remove those from the gap by using the manual editing tools for the gap. You can alter the nodes to remove, say, an area such as this, so that it's not all considered gap. Those that you can do with the manual editing tools within the gap detection. Yes.
And there are actually no further questions at the moment. So
if there are no further questions here, then I'll jump back into the presentation and just throw up the last slide. And this is actually just to thank you for your time. Remember, again, the webinar has been recorded. So if you missed a piece of it, then please, you'll be able to find this recording available after the webinar has been completed within the Trimble Geospatial webinar webpage. And you may take 1 or 2 days to get this uploaded, but it will be available there. And if you have any questions that were not answered here during the webinar, please feel free to contact us. The best address for this is to contact our support team, and you can write them simply an email at support@ecognition.com, and we will be happy to discuss any of your questions with you. And finally, eCognition 1.3 is available now, and if you are one of our customers currently under maintenance, you would have been notified about this yesterday. You can download and install this product, and I hope you enjoy the new gap detection features, as well as new improvements to the reporting, and of course the bug fixes that we have included. And for that, I will then sign off. Thank you very much for attending, and again, please let us know if you have any questions.